Good morning, good morning. Welcome back. Okay, what I want to continue with is mathematics. Of course, GCSE. It's okay, sorry, I'm just trying to put my teeth in. GCSE, okay? Key stage 4. But remember, this applies to whatever stages you're at, okay? It's knowledge that you need to progress in mathematics anyway, to make sure you understand it and you appreciate it for what it is, okay? Something's bugging me here. Why am I so low? It's okay. I'm just trying to get my camera right. Right. It just looked a little bit low for me at the moment. But that's fine. But that's where we're at. Okay. Now let's look at what we're going to be looking at. We're going to be looking at fractions, types of fractions, changing mixed numbers into improper fractions, changing improper fractions into mixed numbers, equivalent fractions, addition and subtraction of fractions, multiplication and division of fractions, fraction of an amount, use of calculators for fractions, problems involving fractions. Okay, I think you got the message now. We're doing fractions. Okay. Right, fraction. Just ignore the at 2.4. That's not relevant to yourself. It's only a marking identifier. That's all. Nothing to be concerned about. A fraction is part of a whole. Okay, and here we have. Let me use my pen. Let me get my drawing tools out. Okay, and I'm going to use purple in this case. Okay. A fraction is part of a whole. And here we have 1/4, okay? So that quarter there is represented by this portion of your circle, okay? The top number tells us how many parts we have. And here we have 1 part out of 1, 2, 3, 4, okay? And the 4 identifies as the number of parts in the whole, okay? So here, 1 represents the part of the whole, and the number at the bottom represents the whole part, okay? The top just tells us how many parts we have taken from the whole, okay? Now, the bottom number tells us how many equal parts the whole is divided into, and that will work as well, okay? So we have 1, 2, 3, and 4, okay? And that's what that number is there. That makes up that, okay? Now, looking at this here, we have 3 eighths, 1, 2, 3 eighths. And what we've got done here, we've divided the whole into 8 parts. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay? And that represents the bottom part of our fraction. Okay? And those parts we've taken, we've marked off. 1, 2, 3 represents the top part of the fraction. Okay? Now 5/6, and here we have again similar thing, principle would still be the same, 5/6, 7/9, 3, 6, 9. Okay. Now the shaded area is shown as a fraction. Okay. So here we have 7/9, 5/6, 1, 2, 3, 4, 5, 6. Okay, and so forth. We call the top number the numerator. Now this is very important. Remember this number for yourselves. Okay. The top number is called the numerator, the bottom is called the denominator. I will repeat that again. The bottom is called the denominator. Numerator. Let's get that right. Numerator. Let's finish that off. Numerator. Okay. Top part. Okay. Denominator. Okay. Denominator. Okay. Now type of fractions. Proper fractions. These are fractions where the numerator is less than the denominator. Again, now let me repeat that. These are proper fractions. Proper fractions. These are fractions where the numerator is less than the denominator. For example, 5/7, 1/3, 4/9. Proper fractions are also called simple or vulgar fractions. Now, improper fractions. Improper fractions, these are fractions where the numerator is greater than the denominator. Example, 12/5, 16/7, 17 seconds. Improper fractions are also called top-heavy fractions. Okay? And again, make sure that you identify the different types of fractions. Mixed numbers. A mixed number has two parts. A whole number and a proper fraction. For example, 2.5, 3 3/4, 5 2/9. 4 3/8. Okay, 4 3/8. 7 2/10. And so forth. Okay, and so forth. Two and a half, 3 3/4, 5 2/9, 4 3/8, 7 2/10. Okay. Changing mixed numbers into improper fractions. Let us look at the mixed number 3.5. We have 2, 4, 6, 7 halves. So this 3.5 mixed will actually equal to 7 halves. Now to bring this to a improper fraction, let me just go back a little bit, make sure that Okay, to bring this to an improper fraction, what we have to do is we have to take this and multiply it out. Now, you can do that there, but life becomes simpler when you simply take that. We have 3.5, okay, and we need to bring it to an improper fraction. So this one, I'm going to put the equal sign here, equals 3 and a, sorry, 3 and a half, okay. That's going to be equal to, so we times the 3 by 2. So what we're going to do, that's going to equal 3 times by 2, okay. And we still have all halves here, okay. So all I've done is to take, we still have all half here, okay. Let me just retain the half, okay. 3 times by 2, okay, equals 6, okay, equals what? Okay. So I'm going to come down here now. Just follow me down, okay? Bear with me. I'm just trying to do. Now, you can do this yourselves in your own format and in your own style of learning. So, 3 times 2 is 6, okay? So that brings me down here with 6. One over 2. Okay. I now need to add that 6 to this one. So I'm gonna, that's going to be a plus sign here now, okay? So 6 plus 1 makes it 7 over 2, okay? And that's our improper fraction, meaning that the number at the top is heavier than it's bigger than the number at the bottom, okay? Now, each whole one is made up from 2 halves. And here I've look at showing you my method, okay, of arriving at that solution. I'm now showing you another method which you may find to be more palatable to your learning style and to your learning method, okay? Again, adapt your own style of learning. It is for you to do that. No one else can adapt that style for you, okay? I'm just showing you my application of my style in how I would approach it. This does not mean to say that you will approach it in the same way, but you will approach it in a mannerism which leaves the principle intact and the solution ending up the same, okay? Each whole one is made up from 2 halves, so there are 7 halves altogether in 3.5, yes? And here, what I've done here is exactly what he's now doing, okay? And you can apply this principle here, if you like, okay? You can see what he's doing here. That equals 7 over 2, okay? Which is the same as I've got here, okay? Okay? Right, okay? Multiply the denominator by the whole number, then add the numerator to give a new numerator, okay? And that's what you need to be able to do. Practice this for yourselves, write it out. Do not just think you can do it off the screen, it does not always work, okay? Changing improper fraction into mixed numbers, okay? Let us look at the improper fraction, 4 over 9. And again, here, let me again take this for you and show you how I would approach it. Immediately, that would be equal to So what I'm going to do now, I'm going to divide the 9 by 4. Divide the 9 by 4. 49 goes 49 goes twice. Which equals 2, which equals to 2. Because the 2 they has gone 4 and gone into 9 twice, that leaves me 2 and remainder 1. Remainder 1, okay? Therefore, that is equal to 2 and 1 quarter. Okay? But let's look at it from a different perspective as well. 9 quarters means we have 9 quarters. 4, 8, 9. 4 quarters make 1 whole. So 8 quarters makes 2 whole ones. We now have two whole ones and 1 quarter left over. So 9 quarters equals 2 and a quarter. And you can see my answer here tallies with what we have talked about here. So just now and again, let me just, sorry, I'm just going to go up. And you can see that my answer here is exactly the same, okay? I'm just looking at it and trying to apply it in a manner where it can be interpreted in a different style of learning, taking that into account, okay? Now, I have no qualms about making mess on my screen, okay? I don't want it to be perfectly nice, because that's, when you're doing mathematical work, it is never perfectly nice. You scribble out, you write out, you practice, you make mistakes, you look at it again, and then you rewrite it again and again if need be, okay? So here again, we've done the same thing here, okay, as I've done up here, okay. So nothing too abstentious, okay. And this is exactly a very good method of learning, okay. And that's the end result. Okay. We'll just make sure I've gone up and that it's in place, okay, and I've not left anything out. Because sometimes when I look back at it, it gives me an issue. Actually, okay, so good. Okay. Now equivalent fractions, okay. You can see from these diagrams that 3/4 is exactly the same as 6/8 and 12/16. Okay, and those would be equivalent fractions. Okay, we say that they are equivalent fractions. When we change a fraction to an equivalent one, we must always multiply or divide the top and bottom of the fraction by the same number. Okay. So here, what would go here? We need to divide 30 by 5 to get 6. So what would go on the top part? You tell me. And we would divide the top part by 5 to get 5/6. So that there is that here, okay? And that's the answer here, 5. Okay? We call this process of changing to an equivalent fraction with a smaller denominator, simplification or cancelling down. Okay? That's what you need to be able to do and understand. You must be able to cancel down. Okay? Arrange 1/4, 3/8, quarter, 7/12 and 9/24 in order, starting with the smallest fraction first. Solution, okay? Now this is for you now to be doing. 24 is the smallest number that 2, 4, 8, 12 and 24 will divide into exactly, okay? And here's the process, okay, that we would apply. Deal with it one at a time, okay? Okay. Here we are, the next one, okay, again. Deal with it one at a time, stage by stage. Do not try to do it all at once. Okay, it does not work. Stage by stage. Okay. And this works every time. You cannot go wrong. (9/24) is already in the form we require, so increase in order the fractions are, okay? And here's your answer now, okay? And you can see that there. And we can have our end result here, okay? Now this is for you to do, write it out. Do the calculations, the multiplication yourselves. Find your level and your method of learning and your style of learning. Apply it for yourself. This is important. Okay, answer these for me, please, okay? Again here, these are for you to do. Get on with it, okay? Addition and subtraction of fractions, okay? Here we have addition of fractions. Okay. Now you need to look at these very carefully. Okay. The bottom, these numbers here is what matters. It gives you your common denominator. The denominator here is 8. Okay. 8 and 8. But in this case here, your denominator here is going to be 12. Okay, because 3 times 4 is 12. And again here, your common denominator here will also be 12. Okay. But remember that you have to convert it to a top-heavy fraction first, okay, before you can proceed. And here's the process that solution which has been brought into play. Let me just get a number. I don't want to use red because red doesn't show up too good on the screen. But let's use a darker color. Okay. Yeah, okay. Solution for A, okay? And here's our solution for A. Make sure you can follow it through, okay? That's solution for A. All of it is relevant. Solution for B is also here, and that too is also relevant, okay? Let me see if it goes down to the next page. One sec, wait for a moment. Let's make sure. okay, okay, 1 5/12, okay. So make sure you write it out and you apply the principle. Here we have C, solution for C, and that's a little bit larger and a little bit more complex, okay, but the still principle is still the same. Still use the same principle. Apply for yourselves, okay. Sorry for that dip, okay, ignore that. That has nothing to do with it, okay. And D, again D, okay. Here we are again, okay, and G, okay. Ignore that blip for me, please. Thank you. Okay, that happens now and again. Okay, now again, these are, I am not going to do this all for you because I've done enough already. I now need you to do this for yourself. Get the work done. Write it out. Understand the concept. Find your method and the style of learning. It is relevant to you to do that. Right, do these exercises for me, please. Okay. Okay, thank you. Okay, I'm not going to do them for you. That's for you now to do yourselves. Okay. And here we are. Okay. Multiplication, division, fractions. Again, here we are. And again, look at the solutions. Okay, solutions quite eloquent to apply. Multiply both the top numbers top together and then multiply both the bottom numbers together. Okay, that enables you to arrive at a solution. And again here, look at your solutions, use them, okay? Do not ignore them. That is your process of calculation these out. Okay, I'm not interested in looking at making it look pretty. This is work you need to be doing, okay? Not interested. Get it done. Okay. And that process also ties in with that. Okay. Okay. Now work example, okay, and continued this division, okay. No, that's funny. Okay. It's funny because for me, right, I would have invert this and multiplied. But in their style, and you can see that their style of learning is again different, I would have inverted this so we get 8 at the top, 7 at the bottom, and then multiply. But here they've changed the division side to multiplication and turned the second fraction upside down. Yes, okay, what I've just said, I would convert this upside down and multiply. Okay, they've said the same thing here. It's okay, I'm just, look, now you can see how applying different styles of learning and how to apply a method of application to solve a problem that can change, and each person can do it in a different way, but yet arrive at the same solution. And that is the fundamental basis of this. You must be able to arrive at the same fundamental solution. Okay. Okay. Again, here you are, and again I'm going to leave this for you to work your way through. Okay. Before we move on, let us think about the last example. We're dividing, so surely the answer should be smaller. Then why is the answer bigger than 4? Means how many halves in 4 ones? From the diagram we can see that there are 8 halves, of course. And you can complete this as from example A, basically, as it says here, okay? I won't do that for you. I'm going to let you get your work on in regards to that matter, okay? Exercises, please do the exercises them for me, please, okay? They are here for, oh, sorry. They're here for you. It's okay, my mouse just slipped from my hand just now and went all the way and made a squiggly. Okay, it made a squiggly, which I didn't quite want, but that's how it goes sometimes. Right, we sometimes fraction of an amount, okay? So we're looking at fraction of 3/5 of 25, okay? And here's the solution. Apply the solution correctly, and you can never go wrong, okay? And here we are. Basically, you're saying 3 times 25, change the off to an x, because you're multiplying. And all he's saying here is that 75 over 1, you can divide 75 by 5, so that's going to be divided by 5 now, okay? And that will give you that answer here, okay? 5 into 7 goes once, remainder 2. 5 into 25 goes 5 times, therefore that answer is correct, okay? Is correct. Right, now I'm not going to do this for you. Exercise again, get these done for me again, please. I would like you to do these, okay? I don't want to just show them here for my good looks, because I'm handsome and debonair and charming and sweet like candy, okay? And here we are, okay? Using calculators. Now some of you know how to do this already, so I'm not going to spend too much time on this. Using a calculator is easy, but you need to be able to do it from your head because of knowledge that you have obtained, okay? That is fundamental. Work example again, so I'm not going to go anything on that. Mr. Mrs. Alien, etc, etc. Some spot basic price, okay? Okay, so you can see there for yourself. And here we have put in the solution, okay? To make sure that you look and see how it has been done, okay? Do the calculations, work it out for yourself. Fundamentally, without question, okay? Okay, here we have some additional work as well for yourselves. And here we are. Now I hope you found this useful. Let me just make sure I got back up, all the way up the top, okay? And that I got everything in view, okay? Okay, thank you. And I'll make my way all the way up to the top. Just make sure that I got everything in frame and that I have not twisted the camera out of focus while I was talking and banging my mouth. Okay. Okay, excellent work. Thank you. All right, thank you for your time. Have a good day. Bye-bye.